What's up, Algebra 2 crew? Mr. D here. We're going to go through some factoring techniques to break us into our new unit here. So grab out a notebook, something to write with, and then we'll get started. All right, so purpose of factoring, we'll get to a little bit more specifically in the next day or two, but we're going to be breaking down specifically quadratic equations and then some higher other powered functions into linear factors to help us solve for x and to help us find x-intercepts. All right, so we've got 4 different methods that we're going to talk about today. First one being factoring by a GCF, which what you did back in middle school is the greatest common factor. And then we're going to factor quadratics in standard form. And then we're going to talk about just a couple shortcuts to help you save some time. The first one is called a difference of squares. And the last one is called a sum of squares. All right, so if you need to, pause the video for a second to get those down, and then we'll get started. All right, so our first one, factoring any expression, could be a linear factor, quadratic factor, cubic, etc., via a GCF, a greatest common factor. All right, so all we're going to do here, greatest common factor, means that we can pull that factor out, aka divide, out of each one of the components inside the expression. All right, so if we're looking at this first problem, 3x plus 12, what we want to do is we want to take apart the components that we can divide out of both chunks. Okay, so starting numerically, 3 and 12 can both be divided by 3. All right, so now we're not going to divide and just throw that number out. That 3 is going to come outside of the parentheses. Okay, so we're going to do 3 and then open up a quantity. So if we divide this front chunk by 3, what would be left? All right, we'd have a 1. Okay, 1 times anything we don't need to write. So we're just going to bring over the x. And if we divide 12 by 3, we would be left with 4. Okay. So now just to double check, the way that we know that we did this correctly is if we distribute the 3 back through, we would end up with 3x plus 12 right where we started. Okay, so just a nice easy way to check. If you can multiply this back out and get back to what you started with, then we're on the right track. All right, let's add in some more variables, some bigger numbers. Okay, so now we've got 5x cubed minus 25x squared. So we are looking for the pieces in common. Let's start with our numbers. So what can 5 and 25 both be divided by? The biggest number possible is 5. But now if we look at our variables, we also have some variables in common. Okay, so what's the highest powered variable that we can take out of each piece? Each one has at least an x squared inside. Okay, so now we're going to open up a quantity, a set of parentheses, to figure out what's left. Well, if we divide 5 out of here, there would be a 1 left. And if we take an x squared out of here, there would still be an x left. So technically 1x is what we would have left. And again, if we multiply these two pieces back together, we would get back to 5x cubed. Okay, now for the second piece, we want to take negative 25 and divide it by 5. Negative 25 divided by 5 would be negative 5, so minus 5. And if we take out x squared from x squared, there are no x's remaining. Okay, so just a negative 5 in the back piece here. So again, just to double check, if we go back through and distribute this, 5x squared times x is 5x cubed, and 5x squared times negative 5 is negative 25x squared. All right, so you can see we got back exactly where we started, and that's how we factor via a GCF. All right, moving on to factoring in standard form. Okay, so this is specifically when we have the number 1 in front of x squared. All right, so all we are going to do is we're going to open up two sets of parentheses. Since we have to have x squared be in front, we're always going to start with x and x in the parentheses because x times x is x squared. Okay, now our two constants are going to go in the back. Now here's the shortcut. Okay, the two numbers that go in back need to multiply to the back number, so positive 12, and they must add to the b constant, or 7. All right, so what two numbers multiply to 12 and add to positive 7? If you're not sure, let's make a little factor chart here. So our multiples of 12, or our factors of 12, are 1 and 12, 2 and 6, 3 and 4. Okay, so which possible pairs of numbers here could add to 7? Well, these don't add to 7, these don't add to 7, these add to 7. So we know that 3 and 4 must go in the back of the parentheses. And they both have to be positive, since positive 3 times positive 4 is positive 12, and 3 plus 4 is 7. All right, let's go to another one where we change up the symbols here. Now we've got some subtraction symbols in there. So again, we're just going to start with two sets of parentheses. To get our x squared, our x's are always going to go in front. And now we want to multiply to negative 24, and we want to add to negative 10. Okay, so let's list out our factors: 1 and 24, 2 and 12, 3 and 8, 4 and 6. All right, so now using any positive or negative number here, we need to think which pair of numbers could possibly add up to 10. Well, there's two of them. Okay, 4 and 6 could add up to 10, or 12 minus 2 could add up to 10. So how do we know which one is which? Well, we need to look at this back number here. We are multiplying to a negative number, which means one of the parentheses has to have a positive number. The other parenthesis must have a negative number. Okay? So now since one has to be positive and one has to be negative, let's look. Is the difference in these numbers 10? No. So 4 and 6 is not going to work. Is the difference in numbers here 10? Yes. 12 minus 2 is 10. Okay? So we need negative 12 and positive 2 in order for this to factor correctly. All right? So 2 times negative 12 is negative 24, and 2 minus 12 gets us to that negative 10 middle number. Okay? So an easy way to double check that you've got the correct numbers there. All right, last one. Pause the video real quick if you want to try this one on your own. Otherwise, I'm going to run through the solution here. Okay, so we'll always start with x and x. All right, our back number is 8. So what numbers multiply to 8? 1 and 8, 2 and 4. Okay, our back number is negative, meaning one needs to be positive, one needs to be negative. Okay, so which pair of numbers subtracts to be a sum of 7? Again, we need to multiply to here and add to here. So our difference of 1 and 8 is 7. So we want the difference to be positive, so positive 8 minus 1 will add us to 7. Positive 8 times negative 1 will multiply to negative 8. All right, and there's how we factor in ax squared plus bx plus c form. Okay, standard form. All right, let's crank it up a notch. So now we are going to factor in ax squared plus bx plus c, so standard form, but we're going to change the front number. Okay, this gets a little bit tricky. So if you are very good at mental math, you can probably still do this, but I'm going to show you a nice, easy way to get it right every time. I call this the box and diamond method. So we are going to create a 2x2 box, and over here we're going to create basically like a sideways box that I call the diamond. All right, so here's how it gets set up. The first piece, all right, so our A term goes into the first box, 3x squared. Our C term, our last piece, goes into the last box. And now in the diamond, we are going to multiply those pieces together. We're going to multiply A and C. 3x squared times 6 is 18x squared. All right, the B term is going to go in the bottom. Okay, the B term is 11x. All right, so now we're going to do the same thing that we did before. We're going to come up with two numbers that multiply to 18, but add to 11. So if you need to, list out your factors down here and see which two multiply to 18 and add to 11. Okay, it's going to be 9 and 2. But since we also have x squareds and x's, all right, 9x times 2x is 18x squared. 9x plus 2x is 11x. Okay, so the reason for doing this diamond piece is that we need these two side boxes because those are what's going to go inside the box here to complete our square. Okay, now the final step is to factor out GCFs inside of this box. We're going to do the rows and then the columns. Okay, so looking at our rows, what is our GCF? Well, we've got 3 and 9, so out of 3 and 9, the GCF is 3, but we also have an x in each one of these. So we're going to take out 3x, that is the GCF. In our bottom row, we just see that we have numbers in common, so the GCF between 2 and 6 is 2. Okay, the first column, all right, there is no GCF bigger than 1 of 3 and 2, so we don't need to write down a number, it's just 1. But of x squared and x, we have an x in common. And our last column, all right, we don't have any matching variables, but in our numbers, our GCF, okay, so what's the biggest number that you can divide out of 6 and 9? It is 3. And there are your factors. Those GCFs that we just pulled out are your factors, x plus 3 and 3x plus 2. Okay, it does not matter which one goes first and which one goes last. All right, if you want to pause the video and try the second one, feel free. Otherwise, I will run through it again real quick. Again, if you want to try to guess and check, punching in the numbers into the parentheses, feel free. Otherwise, I'm going to set up my box and my diamond. Very poor diamond. Okay, so here we go. First piece is going to go in the first box. Last piece in the last box, that is A and C. We're going to multiply A and C, which is 4x squared. We're going to take the B term and put it in the bottom, which is negative 5x. Now we need two pieces that multiply to the top, but add to the bottom. Again, list out your factors if you want to, but it's going to come out to be negative 4 and negative 1. These two numbers add to the bottom, our B term, and these two numbers, multiply to the top. Okay, we're going to bring those into our empty boxes here. And then we're going to factor the GCFs. Okay, so the first row, we only have an x in common. Our second row, now the first symbol that we hit, we always go left to right, top to bottom on the rows and columns. So the first box is negative, our GCF is 2, so we're going to take out negative 2. Our first column, all right, we have x in common, so let's take that out. We have 2 and negative 4 in common, all right, but the first box that I hit when I go from top to bottom is positive, so we're going to use positive 2. Okay, and in our last column, we don't have any x's in common. We don't have any numbers in common either. The GCF here is 1. That can happen. All right, but as we go top to bottom again, our first box is negative, so we're going to take that minus sign. So x minus 2, 2x minus 1 are our factors. Okay, again, just to double check that, if you multiply these parentheses back out, you should get back to where we started. If you multiply these sets of parentheses back out, you should get back where we started. All right, I only have a 15-minute video. I am out of time. Good luck.